Good afternoon, everybody. Thank you for being here today. My name is Gina Kamal. I am the field CTO of, can you share my screen, please? Of a company called DataBond. We are a data fabric company. And we can talk about that. I wanted to spend actually that session more on something I really care deeply about, is AI and cybersecurity. And I wanted to get a little bit into beyond like it's going to change the world and get more like second level of detail and see what are the applications. So when GenAI first came out 2 years ago, I started kind of doing some work, some of the banks actually on it. And there are more use cases than this. But I wanted to, so I used to be a consulting partner in a Deloitte. So I've done advisory work, but there are so many other use cases for AI and generative AI in the SOC. But I want to focus on these because I find these to kind of be interesting to talk to. And those actually are stuff we kind of have in our solution. So the first thing we kind of see is, from a cybersecurity perspective, we have a lot of data, so much data. And the issue we have with cybersecurity data is to get value out of it, we need to put it on a data lake, I need to put it in a SIM, I need to put it on some kind of storage. And everybody sells you on the amazing thing they can do as soon as you have the data in their system. But the question is, how do I get them there? And I always, hello. And I always joke that when I was, nothing against consulting people, I used to charge my clients hundreds of thousands of dollars to get the data from A to B. It was very expensive. And I remember a project would be like a year and a half, 8 months of that just on the data. And I remember the client would be yelling at me saying, you're just doing Excel sheets. I'm like, it's been 6 months. I'm like, yes, we're doing the data analysis. I'm like, I haven't seen anything yet. I'm like, we need to figure out what the data is. We need to do the connectors for it. We need to create the parsers, all just to get the data to go where it needs to be. So we can actually use AI to do that for us. And I'll give you an example of that. The second layer of this is the insights layer. So everybody had a SIM. We change our SIM every few years. We don't know why, but because somehow it gets outdated or too expensive or something. And a few years ago, actually a good number, I was like, we can do better than that, you know? Or I cannot rely on the SIM only. I want to be able to extract insights from my data anyway, especially if I want to do threat hunting, if I want to do additional analytics, or the crazy concept that we came up with a few years ago but never really materialized, which is a fusion. If you have cyber data together with fraud data and maybe money laundering data, threat intel, you can do something cool with it. And that you need to have this data lake where you can put all of this together. But again, what data and how and what structure, Can we use AI for that? This one also is, everybody talks about RAG. I'll talk about RAG. I'm not sure if you know what RAG is. I'll explain what RAG is in a second for you. How I can create my own chat GPT for my data. Can I do that? Can I create some applications like chat GPT on my security data? That all sounds fluffy. So let's get to the second level of detail. So second level of detail is this idea of what we call a data reef. And that takes me to RAG. RAG stands for Retrieval Augmented Generation. So RAG, in many ways, if you think about a large language model, like in OpenAI, or DeepSeek, or Llama, or what have you, those are trained on the knowledge of the internet, the general knowledge. So if I ask it about, what do you know about this IP address 10.1.1.1, it wouldn't know. Because hopefully that data is not exposed on the internet and the large language model was not trained on. Or if I ask it a question of what is, let's say I work for company Alpha. If I say I'm a contractor in Alpha, what is the work from home policy? It wouldn't know unless that's public on the internet. So what RAG does is that it gives the large language model your internal data as an additional context. So when I'm asking the question, it still has the knowledge of the universe, but it also has your own data with it. The challenge is, how can I make this data in a way that the model can actually give me a useful answer with? So in that example here, using a large language model with your own data, we can create that insights layer, if you will, and then you can have it as like a chat GPT, kind of conversational AI, or some applications. And I will get to that. Any questions up till now? I'm trying to get to peel the layers of the onion layer by layer. Okay? Sorry, I moved too fast, so. Can you see this? I'm hoping, and I don't have my eyeglasses today, so it's also harder for me. So this is just an example of a RAG workflow. And I'm hoping that's not too nerdy, but I think there is value because everybody talks about the stuff and no one actually explains it. So let's understand it. And it's not actually that hard. So what happens? Think of this as your data. Okay? That data could be your logs, could be policies, could be documentation, could be even audio files. It could be anything. Okay? And then what we need to do is we start breaking it into pieces, chunks. Why do you need to break it in chunks? Because the model, to give the model the data, it needs to be in tokens. It needs to be in certain chunks. So I need to break it into chunks. Okay? Fine. So usually, if it's a PDF document, so all the examples everywhere, people talk about it, they're chunking a PDF. So you chunk it by line, by paragraph, by sentence. The biggest first problem is, how do I chunk a log file? It's a bit different. Okay? So we need to do chunking for the data. And then I need to do embedding. Embedding means basically taking the words or the data, turn it into tokens, basically numbers, ones and zeros. And then I store that in a database. So far, so good? Okay, fine. And that becomes the context. Remember when I told you the large language model have its own existing knowledge, and then my own data becomes the additional context. So when the user is asking a query, when I'm asking a question, now you see I'm adding, with the query, I'm adding that context. So the LLM now, when the LLM gets a question, it gets both. It gets the question and the context, and it looks at them like, oh, based on this, here is the response. Hallelujah. Simple enough, super hard. Super hard. Like pull my hair out super hard, because I built this myself a lot of times. And I will tell you why. And I will give you ideas of how to do it better, okay? But any questions on that? Makes sense, okay. So that goes back to my point around what I call the pain of making RAG work in cybersecurity. The first issue is parsing the data. So I have the data in different formats, as I said. To be able to give it to the large language model, it has to be in a format it understands. So I need to parse the data from CSV files, from log files, from MD, from what text, you know? So I need to be able to parse it. That's the first problem, okay? Second problem is the chunking. So I want to be able, when I'm chunking the data, I need to be able to contain the relevant data together. Like, you know, like when chunking logs, I cannot just chunk arbitrarily to say, oh, those columns go here and those columns go on this chunk, because otherwise you lose the context of the log, right? And what if I have multiple log files? That's a firewall that have the IP addresses, but that's another file that has the domains and the host names. How do I put these together? Because the chunks, you know, there is no connecting them. And then we have a lot of data, guys. And security people, it's not like one document every 2 days. We have terabytes of data. And that is what I call rich contextual retrieval. People talk about Copilot. Actually, Copilot is not that good. Why? Because when you ask Copilot for a name, it says, oh, I saw this name in Entra ID. Let's go to Entra ID. Oh, but I didn't want to only Entra ID. I want to see what else you know about this name. I want you to tell me from the firewall logs. I want you to tell me from Active Directory logs. I want you to tell me from the proxy logs. I want to know the whole story. It doesn't tell me the whole story. It just told me the first match, the top ranking match. Okay? Okay, I'm not going to be a bad consultant because I'm not a consultant anymore. I'll give you some answers here, I promise. And this idea of the bad prompts. Bad prompts is when you really ask, so bad prompts means many things. Bad prompts mean when you ask the questions like, what do you know about Dina? I'm like, I don't know, there's 15 Dinas in the company. I don't know what you want me to do. Like, you know, it's like when you ask a stupid question, you get a stupid answer. So the LLM is the same. I'm sorry, Octavia, this is my first presentation for me with you, Octavia, I'm sorry. But this is true, right? So there is actually a technique where you can augment the prompt. You take the user's question and say, what is the user trying to ask? And actually we have a way, an additional layer, where we enhance the prompt. So when you give it to the LLM, it's a better worded question. Or to say, well, that question you're not supposed to ask, which is like, what is your password, for example, you know, or tell me all the passwords. So you put controls on this. This one is also a key point on being able to provide contextual rich retrieval, like getting the answer, is actually thinking about the user persona. And I will tell you why. Because we actually, to have the large language model give you better answers, we actually gave it something called few shot learning. We gave it examples of good answers. But when you give it example of good answers, you need to be mindful of the different personas, you know? So because the security investigator questions are not necessarily the question that the business CISO will ask, or the CISO will ask, or a regular user would ask, you know? So thinking of that is very important. And people ask this question, should I use OpenAI? Should I use this? Should I use that? And there's so many, like the graph I showed you, each one of those had its own technique. And we can spend more time on this, but that's also an interesting question. And obviously, as security people, we cannot really not mention that, you know? So I shared, is it doom and gloom? Like you're gonna go home now? Like there's no way you can make this work. So let's give you, so here is what we do in my company for you to just think about it. And I'll give you example from behind the scene and I'll give you like a demo at the end. Like, ta-da, you know, it works. So the first thing is that parsing. You know, so that parsing is the key point. So what you need to do is to make sure that you have consistent format at least. And there are actually a lot of parsers in the market. But what we found is that parsing at scale is quite hard. But what you need to think about is normalizing to that consistent format, whatever that format is. And then what we end up doing is that enrichment. Then enrichment, what we end up doing is we actually create a graph database, like Neo4j or Linkarius, or there's a number of graph databases, or even LangGraph. Because when you think about the security domain, you have the IPs, like I am Dina. I am on this device with this user, Dina Kamal, with this email address, you know, and that location. That's all related to me. So that graph will allow me to connect all of the points on me, do that like entity resolution. And then when I connect to an IP address, it relates to all my attributes. So that enrichment is trying, as we get all of this data from 15, hundreds of different sources, we start to use them to create that graph, if you will. So we have that context of each entity or each user we care about, okay? And then we actually have a way here to say, well, this is slightly off scope here, but also what we do is, well, for a lot of our customers, a lot of the data you're actually collecting is not actually security relevant. Half of it has no value. It's more like compliance, more like a debug logs we don't need. So even before we serve it to the AI, or even before we serve it to your SIEM or data lake, we actually send it to like a cold storage. So we run some kind of analytics to say security relevant, not security relevant. And we actually save clients a lot of money on that. But then if you think about that data for AI, then what we end up doing is now you can bring your model. So the reality of it is, to be honest, there's not much of difference between models. From our purpose, the model itself, they're all fine. What I found sometimes useful is this data embedding piece. I can, like basically how I can create the tokens or turn it into numer. I can make it more understanding security. Because a bot for us is not a bot for non-security people. A hash is not a hash. So we have our own terminology. Because what it does is, it does what we call similarity search. To do similarity search, it needs to understand the meaning of the word. The meaning of the word for us is different than the meaning for the word for the rest of humanity. So it's true. So we actually do some kind of fine-tuning of those embedding models, and also for those large language models. And actually, it's not that expensive to do. Like actually, I did embedding model tuning for cybersecurity. Basically, I downloaded a massive cybersecurity documents, like gigabytes of data, and the MITRE database, a lot of data, and I used it to basically train the embedding model on the security data. So now to understand security data, and use that to serve it, okay? So that's really how we think about it. I want to go back to the problem statements. On the chunking, there are ways where you do what we call semantic chunking. In semantic chunking, you're basically telling the model to say, respect the meaning of the sentence, respect the meaning of the log. Or you can tell it, you can chunk row by row. And apologies if I'm going too much in the weeds, but these are the stuff that makes a difference between what works and what doesn't work. Any questions? Okay. Can I show you a demo? Just to break the nerdiness a little bit? Please, do you have a question? Okay. Oh, I see I'm with my handy ChatGPT. Oh, can you share can I share another screen? How do I share another screen? What do I do? I'm turned into an AT model.
By the model.
Yes.
The model will basically, so for that context addition, where does it get the context, the model?
Beautiful question. Okay. So this flow is called naive RAG, by the way. So what usually happens is it looks at the query and say the query is looking for Dina and goes to search the vector database on Dina, okay? And so there are many search techniques, right? So usually the techniques usually are called similarity search. So it finds the closest to Dina. Now, the search that's happening is not against Dina. It's tokens to tokens. So it can find Diana, it can find Dana, Zena, whatever it finds closest, it will give me. And it's the first match. So if there is 15 Dina there, it will give me the top one. That's what I mean by naive RAG. So there is a lot of art there's something called re-ranking. Re-ranking is make sure that you reorder based on each time what I'm searching for. Or you can add an index. So if I have 1,000 documents, at least I know what each document is about, or what each log is about. You know? For example, if I'm searching for an IP address, to say, oh, I have here, that's the IP address searches. So there are different techniques. So when I told you about how we use graph, what I actually do is, so that I put the graph database here. So when I'm giving the chunks and the embeddings, I'm not just giving Dina, I'm giving Dina with that IP address, with that name, with that domain name. So everything is attached in the same row. So when they get chunked and put in database, they are put there together. So instead of having to look for it all over the database that has millions of rows, I'm just putting all the information on the one user together in one chunk, in one lump. So when I'm searching, yes, it works. Okay, what the fuck? Okay, sorry, no cursing. I'm sorry. Okay, so that's our product. I want actually two things. So we basically collect data from any. I'm not trying to do a demo, but very quickly. To basically all sources to destinations. But one of the cool things, remember the engineer in a box? So here, we have out-of-the-box connectors for all your data. But we actually discover data. So here, this is a new app I haven't seen before. And you see, I'm just looking at the raw data. And I just said generate parser. And it creates a parser for me. It will, I promise. Otherwise, there will be lots of yelling. Okay, so you see, it created the parser. And I can actually tell it, no, that's not enough detail. Don't be lazy. More details. So that, it's running. Yeah, I think it did give more details. So basically, it took the raw data we haven't seen before and using a mix of regular expression, but also AI to say, well, that is typically an IP. That is typically domain name. That is typically a URL, and map it to the right format. So that parsing usually takes weeks. Now we're able to do it like that. Okay? So that is something to think about. The other thing I wanted to show you is going back to, so here, when I told you the contextualization, that when I say search about that IP address, it gives me all, so here I'm creating like a chat GPT based on your data. But in that case, you see, I've seen that IP address in that environment in that date, you know, primarily on that intralogs, but with this user from that location, and I also looked at virus total. That's meant by the full context. That doesn't happen by default, you know? So, and that's what it needs to happen at the back end, as I showed you, you know? I want to show that I want to see how the sausages make, if it makes sense. Okay, if I can go back to the slides, I'm sorry. There's also something I wanted to spend a few minutes on, if you allow me, which is agentic AI, because everybody talks about agentic AI. So let's decipher. I don't want mountains. I really want my, okay, fine. Okay. So, what is agentic AI? Agentic AI basically is a loop. Honestly, it's a loop. You know, it's supposed to do something, and it checks, have I done it enough? No, and I keep doing it until I'm satisfied, and then it stops. That is really what agentic AI. It's a more of a workflow, but the workflow needs to have a loop function in it. If it's not looping, then it's not really an agent. So in that example for that, the parser, it took a bit of few minutes, not a few seconds, because it did the parsing. Is this good enough? So it has a critique. Like it has someone that does the work, not someone. It has like an agent that does the work, and it has a critique. And it criticizes, is it good enough? Yes or no? Until it gets to a certain threshold, and then it stops. So this is the same RAG we talked about. So we start, you see here, it rewrites the initial query. going back to bad prompts. So we have an agent that actually, and basically it's a very simple query to say, basically this is like it's like almost like a mini ChatGPT saying, if you get a query, make it written in a more professional way and try to make it as extensive as possible based on the information you know. Literally, that's kind of what the agent is supposed to do, and we cannot tell it that. So now we have a new query, and then you see the agent says, do I need more details? So I have an agent that is more of, the curious Mary. Do I need more details? Okay? And if it needs more details, what does it do? Like I built actually this agent that says, let's search the internet. So here the agent has what we call a toolkit. So that's what we call a research agent. The research agent, basically, I give it tools, and from the tools, it has a tool that says, go research the internet. Go look in research papers. Go to my threat research database and do web scraping and get everything, So it does that for me, or it says, I actually have the internal data. I can use from internal data. Okay? So in that case, I'm getting more information. So that more information, you see, I'm feeding it with the query. You see now the context with the query. It goes to the prompt. So now, the same idea, but now the LLM had that glorified, enhanced query along with enhanced context, and now I get the response. But then you have an agent that's saying, is this a good enough response? Being your advocate. I actually had one that says to write LinkedIn articles for me. But I do declare, if they are not written by me, I do write in the bottom. And actually, I had like an agent cluster. I had the writer, and an editor, and a publisher. Because that's actually an example on the internet. I just made it for cybersecurity. So they kind of keep working together, and you're actually running the debug. The kids are almost yelling, like, it's not good enough. Go do it. No, it needs more details here. And then I get this very nice written document. So it's kind of beautiful, right? I don't think it's gonna get rid of any of us in the room, but damn, it makes our life much easier. So that's what I wanted to show you today. I feel you guys are like, wow, that was like I hope that was a fun ride though, no? Do you have any questions?
So let's talk about top 2 or 3 use cases, SOC use cases. If you can give examples.
For RAG, you mean? So I really found it very helpful for security investigation. So if I may show you, actually, can I go back to the mountains? And are you still here? Hello? So I'm going to show you a few use cases from. Okay. So this one is called. I love this one because it's kind of creepy. Well, that doesn't sound right. But in this example, actually, so this is a SOC example. Basically, in that example, we took the closed cases from the SOC, okay? And as the analyst is investigating a new case, we're doing QA on the fly. And we're also comparing against the standard operating procedures. So we know, so the AI knows what is good from the SOPs, and if the analyst writing the notes is like, oh, I think you missed that. Oh, that's actually, no, you missed this step. You see the comments? So typically, and I always say this, and it's a true story, my own kid, he was an analyst at one of the banks, and in the shift, they will always have a security analyst doing QA. So that you have one FTE doing QA in the SOC, but here it's done by AI. And in that case, the data I'm ingesting is, standard operating procedures and an analyst notes. And that's actually an easy use case because I don't have a lot of data. It's just text. So I'm basically saying, compare to what the analyst is writing, compare to what should be written based on the SOPs, and give recommendations. You know? So this is just an example. The other example I gave you is that chat, if you will. The easiest examples I've seen, as I was saying, is that policy question. Having a chat bot to kind of say, what is the security policy in X? What is the security policy on Y? You know, that is actually a very easy use case, and it's a very low-risk use case. You know?
This sector grown to the advanced level of, say, for example, I want to do detection of malicious activity or behavioral. I mean, there are tools today doing the machine.
Yeah.
Machine learning mostly supports the behavioral difference.
Correct.
But are we in a position, or are we grown to that level that this model, RAG model, can do that also, the behavioral analysis?
I haven't seen it yet, and I'll tell you why. Because the large language models are not deterministic. They are very probabilistic. And their job is to give you an appeasing answer. You know, it's not really their job to detect threats. Like in detecting threats, you want to be a little bit more on the supervised learning or even unsupervised clustering. And maybe I'm old school still, but that's really what I think.
Is that what the industry is moving towards in this space?
For sure. For sure. As the LLMs become more sophisticated, and you can see those fine-tuned for cybersecurity, I think you will see a lot of that. Yes. Please.
One more question. Seeing the capability of data ban, if I let's say if I have an incident playbook created from the MITRE framework, fully defendable, I feed that as a base input.
Exactly.
And if I do my investigations, and that I feed that as a, another input should be compared against.
Yes.
As per your definition, I think I'm going to get the delta of what I did wrong in the investigation.
Correct.
Let's say I correct all that. Is it defendable in the code of law? Number one. Number two, do we have that capability to do that alignment and correct our investigations? And would it tell what controls we missed and what we should have done it right? All
Yes.
that, right? So
Yeah.
that's two questions.
So yes, you can do that comparison. Defendant of the court of law, I think the defendant of court of law, it goes back to being able to trace the steps and the explainability. So at least in what we do, we try to be as open and explainable as possible. You know? But the reality of it also is, I always say that it's very obvious what is, like you can see it with your eyes. Like what we've done is we automated what a human would be doing. Like you can see you're supposed to do 5, you only did 3. So it's not like it's an opinion, if you will, And these are the use cases that are very easy to do because it can save on a lot of effort while delivering you value, and it's low risk, if that makes sense, And I showed you that chat to help with investigations. That's actually not easy to do because we had to do a lot of work on creating the right graph, the right contextualization. But as soon as you do it, it makes life so much, because you can now search. We actually search up to 7 years back because we don't have to search through you search through a much smaller data set that's highly enriched. So you can search historically 7 years back in like seconds. So it's ridiculous from the throughput. I know I'm out of time. Wrap up. Thank you so much. I'm around if you want to ask questions.